photoelectric effect. Between 1888 and 1889, Heinrich Hertz, Wilhelm Hallwachs, and Philip Lenard performed experiments that showed that light of specific frequencies incident upon certain polished metals would emit electrons. In all of these experiments, there was one interesting effect. Below a certain frequency of incident light, we'll call it F sub 0, no electrons were emitted, no matter how great the intensity of the light. At and above that frequency, it was found that electrons were emitted, that their number was directly proportional to the intensity of the light, but their kinetic energy was independent of the light intensity. None of these properties could be explained with classical wave theory of light. In fact, classical wave theory couldn't explain why this happened at all. If light were a wave, regardless of the frequency of light, electrons should be emitted. As long as enough energy is delivered by a wave of a large enough intensity, an electron should pop out. And more and/or faster electrons should be emitted as the intensity increases. But again, none of that was seen. Einstein tackled the problem and made an assumption that had been made by Sir Isaac Newton about light long before. You might have guessed it. Albert Einstein theorized that light acted as a particle. And he assumed that the observed energies can be explained by Planck's law, that E equals hf. That is, that the energy of the light hitting the surface was determined by Planck's relationship, not by the classical wave relationship. Since the frequency, wavelength, and speed of light are related by c equals f lambda, we could also write E equals hc over lambda. Planck was actually the first to apply his quantum theory to light, but he theorized that this was only true when the light was trapped in a box, i.e. the black body. Outside of a box, he theorized that light was a wave. Einstein took a different view. He said that light also acts as a particle when it's free. He stated that light energy came in discrete packets of energy. These were later named photons. Again, these photons would have the energy described by Planck. Thus, from Einstein's perspective, light consists of photons, which act like particles. This was another example of how physicists continue to build on previous research and coming up with new explanations.